In this section, we're going to tie in some physics/science into some math today, working together. So, notice my little drawing here. This is me, beautiful. Okay, me back in the day. Now, we're going to model dropped objects. So here's my question. I drop a duffel bag of money. I'm not sure why I'm dropping a duffel bag of money, but that's what's going on. Off the roof of the school. How long does it take to hit the ground? So I'm taking this money off the roof of the school and it's going to drop down. How long does it take till it hits the ground on the bottom? Okay. Now I tell you the height of the school. So from here to here is 145 feet high. Okay, we can figure out how long it's going to take if we know the formula. So I need you to know this formula right here. Mark it down. But it's only for dropped objects. If I threw this money up in the air and then down, it's something different. So make sure it's only for dropped objects. Here we go. Know this formula. This h in that little zero beside it, that means h sub 0. This means your initial height. H-I-G-H-T of the object. This negative 16 deals with what's going on with this object. It's going down. Why is it going down? Because of gravity. So this number deals with kind of gravity here. T is your time in seconds. Okay? And H is kind of like your final height. Really technically it's called your height after t seconds. So height after 5 seconds, your height after 2 seconds, whatever you're looking for. But I just kind of generalize and say, it's your final height. So here we go. So what do you need to know? It says, how long does it take? That means I'm trying to find t, right? Time. So I'm looking for time. If I have to look for time, I have to know this and I have to know this. I have to know my initial height and I have to know my final height. Well, it's all here in the problem. How long does it take to hit the ground? What's the ground? How high is the ground that you stand on? 0, right? Right? It's 0, and then you are so tall. So what you're standing on is 0 feet tall. Okay, so this means h is equal to 0. This h, your final height is 0, right? What about your initial height? Do we know that? Yes, I told you. 145 feet high, you're standing and you drop it. So this is your h sub 0, your initial. Okay, I don't know why it's not doing this very well. Your initial height. Okay, so all we have to do is use our formula and solve and we're in good shape. So h is equal to negative 16 t squared plus h sub 0. Let's plug in h. The final height is 0 feet above the ground because it hits the ground, equals negative 16 t squared plus the initial height is, I told you, 145. By the way, it has to be, h has to be in feet in this case, and this has to be in seconds. If it's different, you change it. Okay? Now basically all you have to do is you have to find t. Should we factor? No. There's no bx term, right? You don't see ax squared plus bx plus c, no bx. So let's get t by itself. Move 145 by subtract 145 minus 145. And you get negative 16 t squared equals negative 145. Get t by itself, so negative 16 divide by negative 16, and then you get t squared equals, we'll just say 145 divided by 16. And how do you get t? You square root, right? You square root. So t is equal to basically square root of 145 over 16. Now technically it's plus or minus, right? But you can't have negative times. So really it's just the plus. So put this in your calculators. Square root 145 divided by 16. Enter. And you should get a number 3.01. 3.01 seconds. Okay, 3.01. That's the time. There you go. That's how you do these problems.